Okay, ladies and gentlemen of geometry, let's get talking about this last question. So this is the analysis question, the one that came at the very back, very last page of the quiz. Um, and really, this wasn't as hard as I think people were trying to make it. I think a lot of people kind of looked at the length of the question, the way it was being asked, and just really kind of freaked out, and didn't follow even the very basic hints that we were offering. Um, we weren't looking for anything super deep here. In fact, I mean, I think an answer that got a full four as a rating was only really just a couple of sentences that they'd written out. But the big thing they did, which a lot of people did not do, which is include pictures, a diagram, to help them kind of with their thinking, with their explanation. The root of the question, the big part of the question, is really this part right here in the middle. Um, Explain why we can trust the distance formula to find the distance AB by explaining it why and what its shortcuts. So in other words, this distance formula, well, where does that come from? What are we doing with that? Like, where is the x1 minus x2? What is the y1 minus y2? Why are we squaring it? Why are we taking the square root? The answer to that is actually really simple. It's a triangle. It has to do with a triangle. It has to do with specifically, excuse me, a right triangle. So if I were to pick a distance, AB, and I want to find, I'm sorry, 2 points AB, and I want to find the distance between them. Let's call this one A, and let's call this one B. This can be done relatively easily, especially if this is, say, like on a grid, because these two, no matter where they are as a diagonal line, um, are formatted in such a way that we can create around them a right triangle. So that was a basic observation that had to be made, that even though we were looking at um, a distance diagonally, it really amounts to using Pythagorean theorem, where this is the C value, this is the A value, and then this will be the B value. Well, using the Pythagorean theorem, if I want to find the C value, um, that's the same thing as taking that value squared and setting it equal to A squared plus B squared. Um, so how does this play out, and how does this connect and create this formula? Well, if this was on a grid, A would have the distinct formula, coordinate points of x1, say y1. B would then have to have x2, y2, different x value, different y value. And then the point here that you need to actually form your triangle, so to speak, would be x2 comma y1. Y1, of course, because it's on the same horizontal line as the first point A, and x2 because it's on the same vertical line as x2b. Um, so ab squared would be the same thing as a squared. Well, if a is x1 to x2, that means the distance would have to be the absolute value of x1 minus x2. That's something we talked about extensively in class. So do a substitution when we're dealing with x1 minus x2 squared. B, for the same reason, would be y1 minus y2 as a distance. So as a substitution, y1 minus y2 squared. By simplifying rules and by algebraic rules, absolute value ensures a positive value. But if I square a value, it's going to be positive as well. So we can actually drop that. x1 minus x2 becomes that value. And then same thing here, we'll just use parentheses instead of the absolute value. And that's still equal to AB squared. If I just want the distance AB, I can square root both sides, leaving AB by itself. We don't need a negative value because, well, we're square rooting and it's a distance. Negative values can be disregarded. And so we end up with x1 minus x2 squared plus y1 minus y2 squared. That's why we can trust it. We can trust this formula, this distance formula in the end, because it really just came from the Pythagorean theorem, which is justified by the diagram becoming a right triangle whenever we need it to be one. So I'm not going to give you like, hey, write this down, this is the perfect answer, but this was the gist of this problem. You had to connect the distance that you need to find AB to a right triangle. If it's a right triangle, we can use a Pythagorean theorem. If we have a Pythagorean theorem, then we can show a progression, an algebraic progression, to get to the actual distance formula. Now, you didn't have to actually show this. Like, if a lot of people did not actually show these steps in between, but they simply reasoned that the change in x value is the same thing as this, and the change in y value is the same thing as this. And that was good enough. But again, to get full credit on this problem, you had to relate this diagonal distance to a right triangle, and therefore Pythagorean theorem, and then show or explain. I showed you guys we could explain why the Pythagorean theorem generated this formula, like where this A is coming from, and where this B is coming from, where this C is coming from, or rather where it actually progresses and becomes the values in our formula. Okay? So really that's it. I mean, that's the big idea. We just have to make sure that we're acknowledging where those pieces come from, and then that's going to be full credit. So this question was tougher, but that's the nature of an analysis question. Like, I'm not giving you a direction how to find the answer. You're going to have to actually interpret the question and build your own answer from that interpretation of the question. That's what analysis is really all about. Right? So think some more about it, formulate a good answer, and let me know. So I hope this helped. Thank you.